Hello, I'm Patrick Boo. I'm the product manager for ServicePort and also the cybersecurity channel within ServicePort. And I would like to share with you a presentation that we have done that will cover a lot of the things that's going on today with cybersecurity, how you should protect yourself, what technologies you should use, what you shouldn't use, and so on. And also at the very end, I'm going to talk about implementation strategy, and that will be part 2 of this video. So please continue watching that one. We start with the threats. And there have been examples in the media. One of them, of course, being Stuxnet. That's what started the focus on cybersecurity for industrial control systems. It was in 2010. It was followed by Duqu and Flame, other viruses that actually affected industrial control systems and were really advanced. And Shamoon, that actually crippled Saudi Aramco, an oil and gas producer in Saudi Arabia, in 2012. So there is definitely a risk out there. These are just viruses to highlight on the biggest risk to any control system. We have other risks here. Hacking. There are hackers out there, of course. They do want to cause harm. They're looking for ways to make money. And by hijacking a control system, that could be a great revenue stream. Malicious software is the viruses that could affect any Windows-based computer. It doesn't know if it's a control system or a bank. Unauthorized use will be the third one. Anyone using a control system in a way they're not authorized to will fall under cybersecurity that is defined by measures taken to protect a computer or computer system against unauthorized access or attack. So that is what we're talking about. And in this case, the system is a control system at the plant. Why is cybersecurity all of a sudden an issue? Many things lead to this. One of them is the development from isolated devices to our homegrown control systems with very specialized network. But the technology have pushed all the manufacturers of control systems to use standard equipment, standard networking equipment, standard Windows computers. And that is because we want to leverage all that technology and greatness that exist in those kind of components. So whatever IT problems we have also now apply to industrial control systems. The criminals, they are really good at focusing on the IT systems, banks, insurance companies, governments. Therefore, because we are using IT systems, we are at a higher risk. So what's in the past was not much of a cybersecurity risk, but very complicated, very specialized, is now much easier to use and extract data and value from, but we are affected by these IT criminals. Another important thing to know when you start with cybersecurity is there is a difference between IT and OT. IT is information technology, OT would be operational technology. And the IT folks, they are really, really concerned about confidentiality. How do I protect my data? I don't want credit card information to go out or medical records or anything like that. I want to protect that data to all cost. So with that being their foremost protected thing, they are willing to let go of the availability. They will shut down a system if there's a risk to the data. Take the same thought to the operations technology, where availability all of a sudden is the foremost important thing. You do not shut down a control system. Even if someone is stealing information from it, you most likely will keep it running. This slight focus and difference in priority makes these two teams, they don't operate very well together. It's very hard for one side to understand why the other side behaving the way they do and vice versa. On the bottom here, we have 3 fantastic examples where an IT approach will have a disastrous effect on an industrial control system. So the first one, someone is trying to log into my account with the wrong password 3 or 5 times. They get locked out. The computer is locked down. That is fantastic IT security. It just doesn't work on an operational technology, because if the operator types the wrong password, being tired or thinking of something else, and he's locked out from the control system, how can he prevent something really bad from happening? There may be actually fatalities, environmental disaster, or just lost in revenue. So the solution there is to have deployment guidelines, to actually think about what to do and do it the right way. IT solution, as soon as a new patch is out, you should install it. That works fantastic in the IT environment. Control systems are a bit more finicky and it may not work. So we may actually have a complete shutdown or at least a forced reboot on the system. And again, we cannot have that. So we only install vendor validated patches, and only when we decide to do so. It may not be directly. Modern firewalls and intrusion detection systems, really good on an IT side. They may not be what you want to use on an operational side, because they could cause trouble, they will cause increased maintenance and so on. So again, we have a couple of examples of really, really good solutions on the IT side that will have a really bad effect on the operation side. The other thing that is important to think about when approaching cybersecurity to implement this at a site or a factory is the risk and the cost. Do not spend more money on cybersecurity than the value of the asset you're trying to protect. It sounds really simple, but it's still something to think about. What are we trying to achieve? Are we trying to protect ourselves from an hour shutdown a year, or a complete shutdown on the whole plant, or even affecting a small city? It has to be balanced there, so we are spending the right amount of money. The other thing is we need to think about risk. We're going to circle back to risk throughout the presentation. One way of defining risk is a function of threat, vulnerability, and consequence. Threat, we talked about that. There are threats out there. There's not much to argue that it's not a threatening world to computer systems and as well as control systems. Vulnerability. Every software, every piece of hardware, operating system, network protocol have weaknesses. We may not have found them yet, but they are there and someone will find them. So these 2 first parts of this function, threat and vulnerability, we can take them out of the discussion. And we are left with the consequence. And consequence, I do not know what the consequence is for a specific customer. If you are a nuclear facility, the consequence is pretty darn bad. If you are making meatballs, that's not good either, because you can poison people. If you have wastewater in a small city, it's not good either, because that overflows, you have an environmental problem. So, and if you would say, I have no consequence, I would start questioning, why are you in business? So it comes down to consequence. Each one of our customers, each one of the plant owners will have to define what the consequence is to them. What is the consequence of a shutdown for a day or a week? What is the consequence of not being able to operate, not be able to change things or control things in your process? Another way of looking at this is that you have the cost. The probability of a security breach will drop when the security level increases. When we add more and more security measures, the probability of something happening is going down. It will flatten out. It will never reach 0. You can never be fully secure. The cost of that level of security will, however, skyrocket. When you're trying to improve cybersecurity from fantastic to even better, that is really expensive. What you can also see from this is by You can drop your risk tremendously here in the beginning by spending a very small amount of money. So somewhere in this graph, you have where you want to be based on the risk. What risk are you willing to take? What is the consequence, and how much will you spend for it? So by spending a reasonable amount of money, you can lower the risk tremendously. Dwight Eisenhower said we will bankrupt ourselves in the vain search for absolute security. Obviously, he wasn't talking about cybersecurity for an industrial control system, but it goes just as well with this. If you are setting off a project with the goal, we are going to be 100% secure. We are never going to have a security breach. You will fail. You cannot do that. It's not possible for 100% security or for absolute security. Accept that you will have a certain level of risk, but define how much risk you're willing to take. Follow an industrial standard. There are many standards out there. We have a bunch of them for IT sector. We have a lot of them from the industrial automation side of things, and we have some for the energy sector. Pick one of these that fits you the best. If you haven't picked any one, I will recommend the ISA 99 or IEC 62443 as it's called now. It covers quite a bit of the area, but if you have a different one, that's fine. They're all made from really smart people that are trying to solve the same problem. That's why they're overlapping. But pick one and try to learn from it. Attend a seminar and don't invent things yourself, because someone else have most likely solved the problem for you. Another thing that must be covered in a presentation and speak like this is the myth of air gaps. Very many plant owners believe that my control system sits on my factory floor and I have no electrical connection whatsoever to my office network and therefore the internet. I do not worry about cybersecurity, because how can they ever reach my control system because I have an air gap? First of all, even if you would have this, which I doubt strongly, sooner or later a manager up here is going to say, I want data from the production. I want to know how much we're producing or how much material we're using or what the stock levels are. So someone will go down to the control system where all the data is electronically stored today. And he will probably not use a pen and paper to write up the trend for the last year. Most likely, some kind of electronic media will be used to transfer that information. Most likely USB stick. There you have a connection. That USB stick could be infected and the air gap is being bridged, and therefore that whole argument has fallen flat. It's very, very, very hard to do a true air gap. It can be done, but it's not worth the effort. It's very much more likely that you have a connection between, and this example is when you set it up with a philosophy called a demilitarized zone. It is the best practice approach that is reasonably secure. Basically, we have a firewall here and a firewall here, and this computer network in between is the demilitarized zone. No data is allowed to go from the control system straight up to the office network or the plant intranet. Every piece of data must end up in the demilitarized zone. So the lower firewall will not allow any data to go from the plant intranet all the way down, and the upper firewall will not allow anything to go the other way around. This approach is well documented, it's industry best practice, and it is a very good way of getting data in and out of a control system. So instead of fighting this, saying that I have an air gap or I'm going to do some other special high-tech solution, I recommend doing a demilitarized zone, understand it, and that will be very secure indeed. Moving on to other things to think about. Remote access. Remote access is great. You can get help from anywhere in the world. You can be much more efficient. You can shorten the downtime tremendously. And a very common solution is VPN. It is an IT solution. It works fantastic when you work in the office and you need to get your documents, or you need to print something at the office, even if you're around the world. Very good solution designed for IT. It is not designed for industrial control systems. It is very hard to make compliant. It has access control issues, and it's not recommended for an industrial control system. With that said, you could still implement a VPN solution in a way that is quite secure, but it takes a bit of effort. Let me give a story why, or just a scenario why a VPN wouldn't be really great. I work at the customer site. We commissioned a very big control system. The project is over and I need to leave for my next job. The customer asks, hey, if I give you a VPN connection, you can remote in and help me if I get in trouble. And I'm a very good engineer, so I tell the customer, of course I will help you. There's no problem at all. If I have time, I would log in and solve the problem for you. So the customer gives me a VPN solution. I install it on my sister's machine, on my sister's computer. She works with McDonald's, have nothing to do with industrial control systems. The customer calls up and says, yep, I need help. I'm at my sister's house. I use her computer to connect to the customer's control system. I fixed the problem. Everybody's happy. The customer does not know, do I still work for ABB? He does not control the other end of the VPN tunnel. And if I leave or I get fired from ABB, I can still connect to that customer's control system through a computer residing at my sister's home. That is unacceptable. So one of the solutions, ABB have something we call the remote access platform. There are other solutions out there with the same infrastructure and setup. It is specially designed for industrial control systems. It is a very thought out access control schema. The cybersecurity compliant, so you can fairly easily install this and follow NERC SIP, ISA, ISO, whatever standard you picked. That's what we recommend. Our solution works absolutely fantastic. There are other ones on the market that are designed for industrial control system. So VPN is an IT solution, and just be wary about it. If we have a control system with this normal architecture, control system is down here, we have the demilitarized zone, and then we have the office network on top. What do we need to protect? What should we focus on first? And we should, of course, protect the control system. The office network, that's the IT department. They do a fine job with that. Demilitarized zone, it's a bit tricky. It probably falls between. It could be decided that the IT department take care of it, or it could be decided that the control system folks take care of it. But basically, we want to protect the computers and the infrastructure down here on the control system. So here are things we should look at. Procedures and protocol. Who get access? What can they do? How long can they do that? Do we have someone testing backups? Someone responsible for this and that? It's written procedures, basically. Group security policies are, do the passwords need to change? Can I shut down a computer without logging in first? It's a handful of very basic things. One can look up what is the better way to solve this. And your control system vendor would also have a list of the recommended setting. The last part is where you can do the most and also easiest to understand is the computer settings. Do we have an operating system that is supported? Is it patched with the latest security patches? Do we have antivirus? Do we have any games installed? Why would we have a game on a control system? That's just crazy. So there's a ton of things one can look at to do a fairly simple assessment and actually lowering the risk quite substantially. So if you want to protect something on the factory floor, like the controller or a switch, they're usually in a cubicle. And one really easy way to do a reasonably well protection is to put a switch on the cabinet door. Switch goes off, alarm sounds in the control room, you know someone opened the cubicle. So if a maintenance guy is saying, hey, control room, I'm going to open CBA 05, you know that someone is down there doing something and you can ignore the alarm. If that alarm comes up and you haven't heard of anything, you should ask someone to go down, please go down and check CBA 5, what's going on there. It's a really, really low cost way to be quite a decent security on that level. ABB have a cybersecurity fingerprint. That's a service that we can provide that will assess and help you get started as a customer to get started with the cybersecurity work, to lower the risk, to strengthen the cybersecurity measures, and at the same time learn a little bit about cybersecurity. It's really, really fantastic to get a running start on this effort. Like any service we talked before, it cannot make anything 100% secure. There's just no such thing. If someone is telling you that, they're lying. Time flies. Remember this little fella? Original iPod. It was launched in 2001, the same year as this fellow came alive, and Windows XP is officially not supported after April of 2014. If you're running on Windows XP, you are at great risk. You need to have a plan forward to phase out your dependency on Windows XP. You don't have to do it all today, but you need a plan to do it soon enough. And meanwhile, you can strengthen the security with other measures to really address your risk while you do getting rid of this very unsecure thing. So please take action on it and put it in your plan. Some advanced technologies. Whitelisting is really, really the buzzword right now. It is a very good solution to increase the security level tremendously on a control system. What you do is you put a software in place that will prohibit anything that is not pre-approved to run. So if virus comes into the system, it is not allowed to execute. And therefore, you don't need to worry about viruses, for instance. With any kind of security, as we said, there's no such thing as 100% security. So even a whitelisting will be breached. There will be weaknesses that people will take advantage of. You could still get a virus, but it is quite a strong measurement. My warning with whitelisting is you need to be aware of the effort to maintaining a whitelisted system. Once whitelisting is in place, you cannot install a new printer. You cannot replace a mouse for a different mouse because the driver needs to be loaded. You cannot install or open a software that is not pre-approved. And every time you need to do one of these things, you need to go through a whole procedure to whitelist that piece of equipment as well. So it is very secure, but it is a little bit cumbersome, and one should be aware of these things before implementing a whitelisting solution. You should also be very aware of what system whitelisting solution is validated for and what it works well with. It doesn't work on anything, on everything, I should say. The last part here on this part one on the presentation is how do we deal with the modern system versus a legacy system? So if we have a modern system, we have all the benefits of these commercial off-the-shelf products, normal Ethernet, wireless, Windows, all those modern things that we expect to be able to use. And with that comes familiar interfaces and supports all these modern cybersecurity measures, antivirus, whitelisting, all of these cool things. That is great. The negative side of a modern system is that it's also affected by all the modern threats. It is a networked system, so you have a bigger system to protect. The air gap on a modern system doesn't exist. And you have the commercial off-the-shelf products that have weaknesses in them that hackers and viruses exploit. So, to summarize, the modern system is apply the best practices, do this demilitarized zone, the DMZ, that's to get the air gap myth out of the way and actually say, there is no such thing, I want to transfer data in and out of my control system, and I want to do it in a safe and secure way. Install antivirus, goes without saying. You must have antivirus on a system. Security patching, and so on. So there's a very big benefit. There's a modern risk with this modern technology, but it's also fairly easy to apply the best practices because they were designed for a modern system. All the legacy systems, they're still out there and they are doing great. They're helping producing in all the different kind of manufacturings. We have systems that are 10, 20, 30 years old, still doing great. The positive side with the legacy system is that it was specialized hardware, specialized communication protocol, specialized operating system. That means that very few modern viruses will come in. Very few people knows how to hack it, and they don't care about hacking it. It is relatively secure. The downside, of course, is that it's completely unsupported. So if a virus came in, or any weakness or cyber offense, you have no patch against it. There's no modern defense systems at all. You cannot apply whitelisting, antivirus, nothing like that. So the good thing is that you have fairly secure base of it, but you have no modern protection. So the way away from this would be to upgrade. To put in your long term, we need to upgrade because, first of all, the old thing will be unsupported, so you have a whole different set of issues to address. You can also strengthen other measures. You can make better physical security, stronger procedures and protocol to counteract the weaknesses you have. And the most dangerous is the systems that fall in between. You have a legacy controller that sits on a factory floor, but you're using modern technology, computers to run it. Then you have a really tricky situation. Or you have a system that sits on the brink here that is dependent on Windows NT or Windows XP and it doesn't upgrade it. Then it's really tricky. But there is a way forward for all these to make them secure enough for the risk that you have. Okay, so that's the end of part 1. The next part of the video will be about implementing cybersecurity in a large corporation. So thank you for watching part 1, and please watch the second part as well.